Okay, guys, this is still the Unit 8 final exam review. I had to take care of something real fast, so I'm back. We're currently solving for, we're solving logarithmic equations or exponential equations. And before I move on, just a reminder, there's really three things you'll notice for these problems. We're either going to condense first, which I did in the previous video. You're going to find a common base. We're going to do that in a minute with 4 and 5. And then sometimes we just have to rewrite. That's all we can do. So let's start with number 4. When I look at this, I notice that 9 and 3 have a common base because they both have a base of 3. 9 is 3 squared. When I say a common base, we want to find a number such that we only use exponents to get them the same. So what I mean by here is to get this to a base of 3, that's 3 squared. This is a base of 3, but it's flipped, so I'm going to have to use a -1. So let me write it out. I think it'll make a little more sense. So 9 is the same thing as 3 squared, so I'm going to use that common base of 3. This needs to make up to the numerator. It's flipped, so I'm going to call that 3 to the -1 to flip it back to the top, and then this is the exponent that was already there. When I have exponents raised to exponents, I need to distribute them, so we're going to multiply them, so that's going to give me a -4x. This is going to be a 3 to the -x plus 1. Okay, that's my exponent. Well, once my bases are the same, the only way that these are going to be equal is if their exponents are equal. So my last step is to set the exponents equal and then solve. So I'm going to add x onto this side, and then my last step is going to be to divide by -3. So we're going to do the same kind of thing again. We need to find a common base. So in this case, both of these have a common base of 4 because this is flipped, so it's going to be 4 to the -1. This is 16 is 4 squared, so 4 is that base. So like we said, we're going to flip this. So that's going to give us 4 to the -1, and then I'm going to write the exponent that was already there. And then this is the same thing, so ignore this cube root right now. 16 is 4 squared. And then cube rooting is the same as raising to a 1/3. So as a reminder, a negative exponent flips, and then a fractional exponent is a root. So since I want the cube root, there's a 3, it's going to be 1/3. So if I am going to I'm going to multiply, in this case I'm going to distribute, I'm going to get a -3x minus 2 and a 4 to the 2/3. So I'm going to have a -3x minus 2 equals 2/3. Okay, so now I need to solve these. I'm going to add 2 to both sides. Well, when I try to add 2, you'll notice that I don't have a common denominator, so the first thing I'm going to do is say, okay, well 2 is the same thing as 6/3. I'm just multiplying by 3 over 3. So -3x is 8/3. And then the last thing I have to do is divide both sides by -3. And when I do that, it's going to make my denominator 9. So I'm going to have a -8/9. So another way to think about this is dividing by 3 is the same as multiplying by 1/3. So if I multiply this side by 1 over 3, I'm going to have 8 over 9. Okay? So we said when we solve for x, especially when we're doing logarithmic exponentials, so far we've either condensed, found a common base. Well, if I look at number 6, you'll notice there's no logs to condense. There's really no logs at all. So the best thing to do if you get stuck is to rewrite this. So I'm going to rewrite this as a log because it's an exponential. So I'm going to say the base, remember the base stays the same, so I have log base e, and they flip, of 7 equals 3x minus 2. Well, log base e is the same thing as ln, so it's better just to write it like that. Trying to get x by itself. So the first thing to do is I'm going to add 2 to both sides. Remember, when I add this 2 over, it doesn't combine with the 7. That 7 is the argument of the natural log. It's stuck in there. And then the last thing I'm going to do is divide by 3. Now, you don't have to put the parentheses around the 7, but you have to make sure that you don't add the 2. It's not ln of 9. It's ln of 7 plus 2. I divide by 3. Okay, you're not going to have a calculator for this portion of the test, and so if you see a problem like this, you'll just leave it. You'll leave it like this. Okay, so this is now not sticking out. So I'm going to put a box around this. This was our different things to try when we're solving logarithmic or exponential functions. Try these methods. Okay, so to the back we go. The back actually gets easier. So the first two here are going to be condensing, expanding, and then we're just going to switch their form. So number 8, we'll do that first. When I expand, the first thing I want to do is break this up into multiple logs. So you'll notice I have, I'm just going to quickly rewrite this as x to the 4th times y to the 6th divided by the 5th root of z. So remember, when I multiply things together inside a log, when I separate them, we're going to add between. And when I divide, I'm going to subtract. Another way to think about it is if it's from the numerator, there's going to be a plus sign. It's from the denominator, there's going to be a minus sign. So the first thing I'm going to do is say, okay, my first thing is x to the 4th. So I'm going to have log base 3 of x to the 4th. They're multiplied, so plus, or it's from the numerator, log base 3 of y to the 6th. Now I'm in the denominator, I'm dividing, minus log base 3 of the 5th root of z. Now, when I expand logarithms, the exponents have to move to the front. So this 4 is going to come to the front and going to be 4 log base 3 of x. The 6 is going to come to the front, so 6 log base 3 of y. This is a root. It's z to the 1/5, so it's going to be 1/5 log base 3 of z. Okay. Well, now we're going to condense. Normally when we start a condensing problem, the exponents are in the front, but we've already moved those for you. So if that 3 was here, you need to make sure to turn it into an exponent, but anything with a plus sign goes in the numerator, anything with a minus sign goes in the denominator. So it's going to be log base 4, that's going to go in the numerator, plus sign, so that's going to go in the numerator, minus sign, so this is going to go in the denominator. I would recommend simplifying this one step further by taking that 2 and that 3 and calling that a 6xy over z cubed. Okay. Okay, now we're just going to rewrite forms. This is the easy part. Remember, the base always stays the same. This is a base of 3. So if I want to write as a log, it's going to be log base 3 of 1 over 81. And remember, the exponent's always the answer. Okay. Again, base stays the same. It's going to be 5 to the exponent is the answer of a log, so 5 cubed equals 125. And the nice thing when you rewrite a log is this should now be a true statement. 5 cubed is in fact 125. If you rewrite this incorrectly, you'll get some weird things. So that's a good way to check. So I hope you guys found this helpful. I am going to, actually, I know a couple people asked for a couple more questions, so I'm going to write out 2 more questions for you if you want to try them real fast. And then feel free to put the video. And try them by yourself first. So we'll call this number 12. And then number 13. Okay, so if you want, you can pause the video and give those a try real fast. But I'm actually just going to jump in and do them for you so you guys will have a key for it. So here, remember, we have our 3 methods. We're going to either condense, we are going to find a common base, or we're going to rewrite. So in this case, we're going to condense first. There's a minus sign, which means this is going to be the numerator and this is going to be the denominator. Okay, well, when I look at this, I actually notice that I have something factorable in the top. Oopsies, I meant to factor that. Okay, there we go. Okay, so you'll notice now I'm stuck. As soon as I get stuck, that's when I'm going to rewrite. So I'm going to rewrite this as 3 squared equals x plus 2. Well, let's think about this. What is 3 squared? 3 squared is 9, which means x equals 7. Let's look over here. Nothing to condense. I have no common basis, so we're going to rewrite it. My base is 2. So that doesn't look super helpful. I actually have 2 ways that I can think about this. Option number 1 is I can rewrite this as a common base. So I could rewrite this as 2x minus 2 equals, well, this is 2 cubed. Okay. And if I do that, I know my exponents have to be equal. So that means x has to be 5. Or another way to think about it is saying, well, wait a minute. Here is saying that 2 to the what power, if I ignore this over here, if I just look at this as saying 2 to the what power gives me 8, right? Well, 2 to the third power gives me 8. So this has a value of 3. So I know right away that this has to have a value of 3. So that's another way you can think about that. If you do that, it'll still get you to the answer x equals 5. So that's just 2 more for you to try. This was, as I just rewrote number 7 is something that worked a little bit better. And then one more rewriting one, okay?